Okay, so let's start the last minute revision of chemistry for O level. So we will just limit ourselves in solving the theoretical questions. Let's start. So here, this question is about fractional distillation and separation of crude oil. So let's learn some basics. So what is, first of all, what is a crude oil? So crude oil, it's a mixture of oil. It's a brown, it does have a brown color and is a mixture of many oils. That means it's actually useful. It is actually useful, but when the crude oil is used as a whole, it is useless, but it has many useful things combined together. Okay, and it is extracted from under the ground. Okay, now how the crude oil is separated. Since most of the components of crude oil are liquid, so they are separated by fractional distillation. So how is the fractional distillation carried out? The fractional distillation is carried out first. For example, crude oil. The crude oil is turned into gas. The crude oil is turned into gas, and then it is allowed to condense. It is allowed to condense. So turn back to liquid. And those parts of crude oil which has lower boiling point, they will be collected from the top because they will travel a longer distance before condensing. And those parts of the crude oil which have higher boiling point, they will be collected at the bottom. In the lower parts. So here C has the lowest boiling point. The boiling point of B is slightly higher than C, and the boiling point of A is the highest in this case. Okay. So from here, look, crude oil is inserted, and here is the heater. This heater will turn crude oil to gas. Okay, crude oil to gas, and then the gas will go upward and condense according to their boiling points. So the shortcut of remembering which fraction is obtained when is where is, so here P na pa di lu, sorry, it's like P na pa di lu, and from the bottom it's B. So PE for petroleum, petrol, Na for naphtha, paraffin, diesel, lubricating oil, and bitumen. All right. Okay. So, and from here we will get the petroleum gas, or what we call the natural gas. Okay. So here everything is given, so you can easily answer this question. Which fraction leaves the column at A, B, and C? You will just compare the boiling points. So the fraction A has the highest boiling point, and the fraction B has the moderate, and C has the lowest boiling point. So we can now just answer this question from here. So let's look at the answer. Look, so A is the diesel, B is the paraffin, and C is the naphtha. So why? This is because, look, this fraction has the highest boiling point. So this is the fraction A. This is the fraction A. Okay. Okay, so here some mole calculations are given. Mole calculations are given. So let's leave it for moles. So in this way, the fractional distillation occurs. Now let's look at some uses. Like, natural gas is used for as a fuel for burning, isn't it? Natural gas is used as a fuel for burning. Petrol is used as a fuel for cars, and similarly naphtha, uh, and then diesel, then lubricating oil and bitumen. Naphtha has got another name. The naphtha has got another name. It's kerosene. Okay, so naphtha has got another name. It's kerosene. It's basically used as aeroplane fuel. So in this way, you need to know the basic uses of these components. Okay. Now, this condition, what is the question? This is the structure of an ester. Okay, so ester, we are forming ester from between a carboxylic acid and alcohol. So this is the ester linkage, the COO. This is an ester linkage. So here we have to separate between the C and O bonded in the middle, and this part is the alcohol part, and this part is the carboxylic acid part. Alcohol part is named by ending with "-ile", and carboxylic acid part is named by ending with "-anoate". Okay, so how many carbon atoms are here? 3 carbon atoms are here, so it's prop, and 2 carbon atoms are here, so it's eth. So propyl ethanoate. That means this ester, is formed from propanol, because this was the alcohol part having 3 carbon atoms, and this whole and this, so this ester is formed from propanol and ethanoic acid. And basically what happens, from the carboxylic acid part, the OH lives, and from the alcohol part, the H goes off. This H and OH together forms H2O, and then what happens? This O and CO gets joined together to form the COO. Okay, so that is the case. Now the condition for this reaction is we have to carry out the reaction in the presence of concentrated acids like concentrated sulfuric acid, and we also have to give some heat, because in most organic reactions, covalent bonds are being broken down, and covalent bonds are so that was the condition for esterification. Now the structure of carboxylic acid I've already told. Just need to break down between the CO of the ester linkage, and then so the structure of carboxylic acid is CH3CO. Just attach OH with the CO part. Just remember, a few moments ago I have told that from from COOH, which part leaves? The OH part leaves. And from alcohol, which part leaves? The H part leaves. So when you break down the ester, you do the reverse. That means attach H with the O part and attach OH with the CO part, just like this. So the structure of the carboxylic acid here is CH3. I'm not alcohol is propanol, C3H7OH, and the acid is ethanoic acid. So CH is OOH. This will give. So H goes from here and OH goes from here. And this O and this O joins. So um you get CH3CO. Then let's write this O and the rest of the part CH7 along with H2O. Okay. So here the student told that the distinction between ethanoic acid and dilute hydrochloric acid. So ethanoic acid is a weak acid and hydrochloric acid is a strong acid. So on reaction, so it's a weak acid. Ethanoic acid is a weak acid. It will react slowly, and hydrochloric acid is a strong acid. So it reacts first. So let's do the test. Like okay, so both of these are acids. Oh, so relative strength of the acid. So we need to compare the strength, not the ions present. So just put like sodium metal inside both of these acids. So ethanoic acid will react slowly. That means bubbles will form slowly, and in case of HCl, the bubbles will form very fast. Any solid substance that will react with both acids, any solid substance, any oxide, hydroxide, or carbonate. Carbonate is better because the observation is so clear. You can see the bubbles of gas. Okay, so let's see the MCQ questions. Let's look at some theoretical questions. So this is a possible theoretical question. Okay, so this question is basically about cracking. So this question is basically about cracking. So what is cracking? Cracking means breaking down a large alkane to smaller alkanes. Okay, cracking means breaking down large alkane into smaller smaller alkene. So cracking means breaking down a large alkane to smaller alkene along with hydrogen, or you might get alkane. So what are the product that you will get? It will be informed in the question. Now, why do we need to get, or why do we need to break down large alkane to smaller alkanes or alkene? Because although, listen carefully, although larger alkanes, uh, they have lot of carbon and hydrogen atoms. So about lot of atoms, a lot. And in case of okay, okay. So this question is about okay. So empirical formula, theoretical question. Okay, so here's a theoretical question. Okay, so this is a theoretical question. The table shows some information about two homologous series, the alkanes and the alkanes and the acid chlorides. Okay, the alkanes and the acid chlorides. All right. Okay. So this is a homologous series of alkanes. In a homologous series, one compound will differ from the next compound by a CH2. Okay. One compound will differ from the next compound by CH2. Look, from here to here, there is one carbon difference and two hydrogen difference. Again, from here to here, there is one carbon difference and two hydrogen difference. Also look at here. This is also homologous series. Why? Because from here to here, there is one carbon difference and two hydrogen difference. The COCl, COCl, they are the same. So we need to focus on these parts, isn't it? So let's just compare. They differ by a CH2. So these are also homologous series. And another property of homologous series is that they will all be defined by a same general formula. Like alkanes, they all can be defined by this formula CnH2n plus 2. All right. Okay. And what are the physical properties of the homologous series? All their physical properties increase gradually down the group, only their flammability decrease. Okay. That means as the size of molecules gets bigger, the their melting point, boiling point, flammability, sorry, melting point, boiling point, and all other physical factors. They, okay. So with acid chloride has the highest boiling point here. So this acid chloride has the highest boiling point here. The name is already given. Okay. Deduce the name of the acid chloride, which has the C2H5 OCl. So look, although these are not in your syllabus, so all the hints are given. So look, how many carbon atoms are here? Two carbon atoms. So ethanoyl. How many carbon atoms are here? Four carbon atoms. So butanoyl. Five carbon atoms. So pentanoyl. So if three carbon atoms are here, then propanoyl. Okay. So this is propanoyl chloride. In this way, you have to deduce these answers. Okay. So general formula. Okay. Now we need to deduce the formula of this homologous series. Look. So the COCl, they remain the same in all these cases. So let's write COCl. Okay. Now let's look at these parts. Can you deduce that these parts, they just contain one less carbon atom than alkanes? Like an alkane is CH4, but here it's CH3. An alkane is C2H6, but here it's C2H5. So what can we say? Each of these parts, they contain one less hydrogen atom than alkanes. Okay. So if the formula of alkane is CnH2n plus 2, then the general formula of these parts are CnH2n plus 1, one hydrogen atom less, and they are attached with COCl. So from here, you will then after just writing this part, you will write COCl. In this way, we can deduce the general formula of anything. Now you might ask that why I am taking alkane. Because they have here, they have given the general formula of alkane. They have mentioned alkane, isn't it? So this must have link with this. They will not give any question which is irrelevant. Okay, like this. Okay, combustion product of alkane. So complete combustion. So after complete combustion of anything, you will get the oxides of all the products. Like in alkane, we have carbon and hydrogen. So if you carry out complete combustion, you will get carbon dioxide and water. And if you carry out incomplete combustion, then you will get carbon monoxide and water, and also sometimes carbon. If it's not mentioned in the question that what is the product of complete combustion, sorry, incomplete combustion, then you better write carbon monoxide and balance the reaction. Okay, this is not only the case of only alkane or alkene. This is the case of all organic compounds, that whatever atoms are present or whatever element is present, just give the what we call, just give the uh, oxides of all of them. Okay. So what would we expect the products of complete combustion to be the same? No, we won't expect it to be the same because in the acid chloride, there is also chloride. So we might get some oxides of chlorine, right? But from here, we will get oxides of carbon and hydrogen only. But from in case of acid chlorides, we will get oxides of carbon, hydrogen, and also chlorine. Okay. 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 So this is a question of fractional distillation again. The meaning of saturated hydrocarbon here. So saturated hydrocarbon means all, there are all what? All double bonds. Okay, sorry, all single bonds are present here. Okay, dot and cross diagram of methane. You can easily draw. Importance of cracking. We have already mentioned that we have to produce smaller alkanes, which are more demanding. Okay, which are more demanding. Okay. Look, this is the definition of saturated, all single bonds containing carbon and hydrogen only. You have to write this because they have also told you to define the hydrocarbon. Okay, look at the question. This question has got two parts. You have to explain the meaning of saturated and also the meaning of hydrocarbon. Saturated means all single bonds, and hydrocarbon means contain carbon and hydrogen only. Okay. I think this is easy. You can do it. Okay, this is an ester, carboxylic acid with 4 carbon atoms. So we can do it. The CO2H is fixed. So here is 1 carbon atom. We just need 3 more carbon atoms. It's C3H7 CO2H. So this is butanoic acid. And the formula of 6 member, the 6 member would contain in total 6 carbon atoms. I guess so. Okay, yes. So CO2H is fixed, and we need 5 more carbon atoms. So C5H12, C5H12 is an alkane. So we will have 1 less carbon atom here. It's C5H11. So this is hexanoic acid. Okay, ethanol reacts with ethanoic acid just few moments ago. So from ethanoic acid, that means CH3CO2H, we will take an OH. Okay, let me write it in details. Okay, COOH. We will take OH from here, and from ethanol, we will take the H. So what? And this O and this O joins. So what is the total structure? Look, CH3CO. This is the part from acid, isn't it? CH3CO. And the part from alcohol is OC2H5. O, then C2H5. O, C2H5. Okay. So this is the detailed structure of ethyl ethanoate. Okay, name a reagent that is used to convert ethanol into ethanoic acid. So this is an oxidation reaction converting alcohol into carboxylic acid. So we just need to use an oxidizing agent like acidified potassium manganate. Magnesium reacts with ethanoic acid to form magnesium, ethanoate, and hydrogen. Okay, so this is just the mole. The mole. You can write the ionic equation. It's easy. Okay. What? Okay, dot and cross diagram. This is the part of bonding. Okay. Methyl hydrate underground has no dislike. When it's released. So there's two reasons why methane hydrate decomposes when it is extracted. Maybe methane hydrate, Okay, let's look at the style of answers. maybe methane hydrate. Which one? It's B2. Okay, B2. So maybe methane hydrate. Look, here are some possible reasons. So this one is the most obvious reason. So forces between the molecules are weak. Forces between the molecules are weak. So at high temperature, the molecules get separated. Okay, this is the most obvious answers. As the tool suggests, it's actually just as suggestive answer. Okay, so source of methane. Source of methane is crude oil. Use of methane is burning, and the reaction pathway. Okay, so this reaction pathway. Okay, so here we are having some confusion. Like if you write reaction pathway here, that is also correct. Or if you write progress of reaction here, that is also correct. Progress of reaction. Okay. 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 This is basically not a question of organic chemistry. I don't know why they have given it here. Okay. Now draw the structure of butanic acid. So first of all, let's draw COOH. So we have one carbon atom here. We need 3 more carbon atoms. Okay, so here 4 carbon atoms, that is butanic acid. Now let's fill the other bonds with hydrogen atoms. Okay, we must show the OH part carefully. This is very important. Okay, so you know what is the meaning of weak acid? Weak means it undergoes incomplete ionization or partial ionization. That means the CO2H, this only dissociates reversibly to give CO2 minus and H plus. So since it dissociates reversibly, so it's a weak acid. And how it will show that it's a weak acid? You know, let's put universal indicator. So universal indicator will show like orange color or yellow color. And in strong acid, universal indicator shows red color. Or we can also measure the pH. The pH of weak acids, it's between, I mean, more than 2. It may be 2, it may be 3, it may be 4. And the pH of strong acid is less. I mean, it's 0, 0 0.5, 1, 1.5, like that. So we can also measure pH to show that it's a weak acid. Okay. So here it's a question of fermentation. So fermentation, let's discuss. Fermentation is a sort of aerobic respiration carried out by yeast to form ethanol from glucose. Let's write the equation. Please memorize this equation. This will give 2C2H5OH and 2 carbon dioxide. Okay. Okay. So the reagent we just need glucose, and we need yeast, and the temperature is about, oh sorry, it's ethanol to ethanoic acid. Okay, I'm here discussing the reagent for producing what, ethanol. We need just room temperature, 37 degrees Celsius. 35 degrees Celsius would also do, but the container must be airlocked so that oxygen does not get inside. If oxygen gets inside the container, then yeast will start respiring aerobically, producing carbon dioxide and water. It will not produce ethanol. Okay, sorry for those sounds. So ethanol is converted to ethanoic acid. So what we need to do, we need to use a reagent, which is an oxidizing agent. Just few moments ago I've told that it's potassium manganate 7, acidified potassium manganate 7, and the condition is reflux. Why reflux means returning into the flux? You know, the ethanol is a volatile compound, like it easily gets converted to vapor. So we must carry out this reaction in a state so that the ethanol cannot evaporate or it cannot escape from the container. So we must carry out the reaction heating under reflux setup. That means returning into the flux. All right. Okay. So this is easy. These are theoretical questions. Sorry, these are MCQ questions. Let's skip. Is it a question of organic? I don't think so. So it's a question of, okay. Okay. So here they have asked about the characteristics of homologous series. Okay. So okay. So these are some sort of cyclic compounds. So they are all homologous series. So why they are homologous series? Let's look at the basic criteria. So one member would differ from the next member by a CH2. So they have the same general formula, okay? And one other characteristic is one member would differ from the next member by a CH2. Now, they have asked to deduce the general formula. Now, how to deduce the general formula? Look what's going on. So this is the basic formula, right? So here, look, first look at the change you are getting. Like, look, this part remains the same, isn't it? But with just the this part is changing. Like here it was H and here it is CH3, isn't it? And here this part also contains one less hydrogen atom than an alkane. An alkane has CH4, but here there is one less hydrogen atom. Okay, so let's focus on this part. So this part is the same in both cases. So what is the formula for this part? So it's C3H1, 2, 3, 4, 5. So C3H5 combined with this part. So this part has one less hydrogen atom than an alkane. So a general formula can be C3H5 CnH2n plus 1. This can be the general formula that you can say, or we can also count the number of carbon and hydrogen atom in both compounds. Like, look, so here we have C3H6 and here we have C4. Then how many H? 1, 2, 3, 4, 5, 6, 7, 8. So 8 hydrogen. So C4H8. So look, 3 hydrogen atoms, sorry, 3 carbon atoms and 6 hydrogen atoms, 4 carbon atoms and 8 hydrogen atoms. So just there are double number of hydrogen atoms. So we can write it like CnH2n. This can also be the general formula, right? So both the answers are correct. Anyone can write. Okay, so they are, you might argue that this is also the general formula for alkene. Yes, that is correct, but their structures are not different. Alkene structure, they are, alkane have, you know, in this case the alkene will have straight chain structures, but here these are cyclic structures and they're alkenes. Why? Because between two atoms you would find a single bond. The general formula might be the same. That's not an important issue. Okay, so alkenes, so they are cyclic alkenes, so they would react in the same way such as other alkenes. So in this compound we have only carbon and hydrogen atoms. So if you carry out its combustion, what would you get? We would get carbon dioxide and water only. Okay, so compound D, we have 3 carbon atoms and 6 hydrogen atoms. So let's write the equation. So C3H6 plus, oh sorry, not here. So C3H6 plus O2. Look how to write the combustion reactions and balance them. It's so easy. First write carbon dioxide and water. So how many carbon atoms are here? How many hydrogen atoms? 6. So put okay. So 3. So now count the number of oxygen. So it's 3 to the 6. And 3 minus 2, so 6 to the 6, 9. So let's put the what's the left? Now 2 and 2 get cancelled out, leaving 9 atoms of oxygen. That's here. Okay, so what type of reaction it does with chlorine? Compound B is an alkane, right? Cyclic alkane. So alkanes they would carry out such reaction. The structure. Okay, so the remember isomers the one have same molecular form, but their structure structure. So that compound D has a formula supercritic. So from now we can draw alkene with that formula. Now fill them with the fill this bond. So this is an isomer of compound D because compound D is an alkene, and what we are drawing now alkene. They have already mentioned that draw an alkene. Oh, good. So some organic compounds are given. Again, this is the cyclic alkane. Okay, this is an alkene. This is the carboxylic acid. All right, this is the carboxylic acid. Wait, what? Oh, sorry. The carboxylic acid. Then this is also a carboxylic acid. This is halogenoalkane. This straight alkane. Now, what is the question? Which two compounds have the same molecular formula? Okay, let's count the number of atoms. Look, this compound has got formula C4H8. This compound also has got formula C4H8. So they have got the same molecular formula. Now, what is molecular formula? Molecular formula is a type of formula that tells you only which atoms are present and how many atoms. So here carbon and hydrogen are present, and we have 4 carbon atoms and 8. Same goes for compound B. Okay. Which compound is butanic acid? So it's a carboxylic acid with 4 carbon atoms. So obviously it's this one because there are 4 carbon atoms. Okay. Which compound contribute to the ozone layer depletion? Ozone layer depletion is carried out by compounds which have chlorine inside them. So which compound? It's this compound. This compound would carry out the ozone layer depletion because it has chlorine inside it. Okay, name the compound B. So compound B, it's an alkene. So 4 carbon atoms. So it's yeah, butene. Now, deduce is another formula for alcohol homologous series. So alcohol, they have got OH, and look at these parts. It's all the same, you know. There is one less carbon atom than an alkane. So their formula would be CnH2n plus 1 OH. Okay, complete combustion. So they have got carbon and hydrogen. Oxygen, we are burning with oxygen. So how can you burn oxygen with oxygen? That's not possible. So we will consider carbon and hydrogen only as the elements present here. So if you burn an alcohol, you will get carbon dioxide and water, right? Okay. Ethanol can be manufactured from either ethene or glucose. Okay, from ethene, ethene is an alkene, so it will carry out addition reaction. We have discussed in the class. So C2H4, and here water will be added. So water is like, wait, where is the annotation? Wait. So ethane, um, it's carbon double bond along with water. So we will write HOH. So what will we get? We'll get, the double bond will get broken, and H will get attached with one carbon, and OH will get attached with another carbon. So we are getting an alcohol. Okay. So same thing goes here, like C2H4. We are writing water as HOH. So we'll get finally C2H5OH. This H gets added here. So this is the similar reaction of water or steam with any other alkene. Okay, so here ethanol from ethene and state is condition. Okay, so we have already written. Okay, this one is important. Ethanol from ethene. So C2H4 plus H2O, that means HOH. We will get C2H5OH, and the conditions are, we must give a catalyst which is dilute phosphoric acid. Since water is the product reactant here, so we will be using dilute strong acid. Phosphoric acid is the best. Then we have to use temperature of about 150 to 300 degrees Celsius. All right, and we have to use pressure, that 60 atmospheric pressure. These are the conditions for the reaction between ethene and water. Okay, and we have already discussed about um, fermentation. So here, propanol and acidified potassium dichromate. Acidified potassium dichromate is also an oxidizing agent similar to acidified potassium manganate. So it will oxidize propanol, and on oxidation of an alcohol, we get carboxylic acid. So from propanol, after oxidation, we will get propanoic acid, just like when we are using acidified potassium manganate. Okay, structure of ethanoic acid we have already drawn. Okay, this is a molar math. You can do it. Okay, aqueous bromine can be used to distinguish between ethane and ethene. So aqueous bromine will readily react with ethene, okay, because ethene has a double bond. So the double bond will get broken down by bromine, and the bromine will be added here readily. So the bromine will lose its color quickly. But in case of ethane, the bromine will not get added. Okay. So when we are using bromine with ethene, the color of bromine would change from brown to colorless. We say it as the decolorization of bromine. But in case of ethene, there will be no decolorization of bromine. Okay, ethene reacts with chlorine in the presence of ultraviolet light. Draw a structure. Okay, so ethane, that means C2H6, it will react with chlorine. So we can, so 6 times the substitution will occur because there are 6 hydrogen atoms. Like what? One hydrogen atom will get displaced, like it was 6 and now it's 5. So one hydrogen atom will get displaced by one chlorine atom, and we will get HCl. So you can draw the structure of this compound, and then like C2H5Cl plus Cl2. Again, one hydrogen atom will get displaced, producing C2H4 and Cl2, giving one HCl. You can also draw the structure of this compound, okay, this compound that I've circled. So I prefer to draw the structure of the first compound. So it's like this. Okay. So it's Cl, H, 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 H. Okay. Alkane containing four carbon atoms. So it's very easy. Alkene containing four carbon atoms. It's butene, and its molecular formula is C4H8. It's very easy, right? Okay. Why these questions are here? RF value, carboxylic acid is mole. Okay. We have just discussed about this in the first part. It's the boiling point. Then cracking means breaking down an alkane into a larger alkane. So supply demand means we are getting smaller alkanes and alkenes which have greater flammability. Structure of propane. This is easy. So this said C15H32. It will get broken down into propene. So it's C3H6 and another hydrocarbon. So here is 15 and here is 3. So we have to put here how much? 12. Here is 32, here is 6. So we have to put here 26. C12H26. Okay. In this way, the product of cracking will be given. Okay. Propene is used to make alcohols and polypropylene. So propene, let's draw the structure of propene. So this is propene, H, 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 H. So we need to draw the structure of polypropylene. So before drawing the structure, we must focus on this double bond. Okay. And let's write. Okay, let's redraw the structure, just focusing on the double bond. Okay. So with this carbon atom, we have two hydrogen atoms. So let's write H, H. And with this carbon atom, we have one hydrogen and one CH3. One hydrogen and one CH3. All right. Okay. Now, how to draw the polymer? It's easy. Look, I'm showing you. Okay. So this is a repeating unit of the addition polymer. So how many repeating units did it show? Or at least two repeating units. Okay. So we will just remove the double bond and draw this monomer twice at least. Oh, sorry. H, CH3. Draw it again. H, H, and CH3. Okay. They said at least. So you might, so you may also prefer to draw another repeating unit. That is three repeating units you can draw. So what is the trick? We first need to redraw the compound in this way, focusing on the double bond, and that is a repeating unit. We call it monomer, and from there we can draw the polymer. It's easy. Why these questions are here? Okay. So this is petrol is obtained from crude oil, actually by fractional distillation. This is mole math. Homologous series. So it's a group of compounds with same general formula, same type of reactive groups are present. Okay. Estimate the boiling point. So boiling point of what? Estimate the boiling point of butanol. Okay. So from here to here, it's about uh, 12, 13 difference. From here to here, it's about, you just need to follow a trend. So here is 13 difference. So here is about what, 20, so no, it's about 19 difference. Then it's about 39 difference. Okay. So you know, 1939. So let's give it a 40 difference, 20 difference. It's your wish, but the boiling point has to be greater than pentanol. Okay. Write down the formula of hexanol. You can do it. Hexanol has got an OH and with 6 carbon atoms. It's C6H. If it was an alkane, so it should be C6H14. So it's C6H13 now. Ethene and steam, we have just seen this few moments ago. Reaction taking place, it's an addition reaction, the hydration reaction. Then the small math, CFC. No, you just learned about glucose. So from biology, you know that at 60 degrees Celsius, the enzymes are already denatured, so the rate of reaction would decrease. Okay. Characteristics of homologous series we have discussed. The pentane predict the boiling point in a similar way. You have to do it, just follow a trend and give it a number. Bond breaking, bond forming, it's easy. Methane is an atmospheric pollutant. Give one source of this pollutant. It may be, you know, the decomposition of dead dead living materials, and also the crude oil, organic compound, fermentation. So basically, look, same type of questions are appearing again and again. So this is CH3CO. This is the acid part of the, look, COO. This is the ester. So let's break down from the middle. So this is the acid part. This is the alcohol part. So this is ethanoid and this is ethyl. The alcohol part will have you know, il, and the acid part will have anoid. So here in this reaction, small molecules are lost. Small molecules are lost. So these are type of condensation reaction. Name the third member of this homologous series. So what was the homologous series? What was the homologous series? It's not given. Oh, sorry, alcohol. So third member of alcohol. So alcohol has OH. So it has 3 carbon atoms. It's C3H7. It should be C3H8 if it was alkane, but it will have 1 hydrogen atom less due to presence of a functional group. If a functional group is present, then the whole compound will have got 1 hydrogen atom less than alkane. This is very important. You can draw the structure, it's very easy. Still, let me show. First draw OH, then draw 3 carbon atoms and fill the rest of the bonds with hydrogen atoms. Okay, okay, no need, no need. Okay, no need. Unfortunately, I don't know how this question appeared here. Okay, these are MCQ questions. You can answer them. It's easy. It's easy. We have already learned about these reactions. Okay, manufacturing ethene. So ethene is an alkene. Alkene can be obtained from what? Alkenes can be obtained from alkanes by cracking. Okay. Alkenes can also be obtained from an alcohol by dehydration reaction. Okay. The equation for the process one, we have already discussed about it. Fermentation. So positive taste of carbon dioxide, we already know that lime water turns milky or cloudy. Okay, no need. No need. This is easy. So methane, why do you need to be concerned about methane? Because methane is a hydrocarbon, and all hydrocarbons are also greenhouse gases. They might be responsible for what? Increase in the temperature of the earth, right? Okay. So here we have another question. It's not in our, the concept is not in our syllabus, so you have to be very careful and you have to use your brain. Okay. The concept is not in our syllabus, so they have given all the information here. Okay, ethine, propane, then we have, so we have ine ending with ine, so it should be butane, isn't it? Butane. Okay. So butane. So now draw the structure of propane. They have already told initially. They have already told that there are carbon-carbon triple bonds here. Look, carbon-carbon triple bonds. So propane, just draw that carbon-carbon triple bond part, and propane means it will have one more carbon atom. Now fill the rest of the bond with hydrogen. So this carbon has already 4 bonds, but this carbon has got 3. So draw one hydrogen atom here. Okay. Estimate the boiling point of hexane. So hexane, just follow the trend. I'm not going to the details again. And from here to here, just, this also homologous series, isn't it? It's already told. So one member of homologous series will differ from the next member by a CH2. So from here to here, just add a CH2. So it should be C6H10. Okay, adding a CH2. Okay, the reactions. Okay, mole calculations. Aqueous bromine. So here, ethylene, it has got triple bond. That means it's also unsaturated, isn't it? So it's also unsaturated. So ethine, okay. So ethine, carbon-carbon triple bonds. Okay. So in case of alkene and alkene, you remember that if we break one bond, then we will get 2 more bonds. But here, to convert it into a carbon-carbon single bond, we need to break 2 bonds. So how many more bonds we will get? We will get 4 bonds, isn't it? 4 bonds. So we will have all the bonds bromine added. So the formula would be C2H2Br4. Okay, like in alkene, when we are breaking just one covalent bond, then we are getting the scope to produce 2 more covalent bonds. So in the 2 covalent bonds, 2 bromine atoms will be added. But here, to convert it into a single bond, we have to break 2 covalent bonds. Okay. So what we will see, did the reaction, that means bromine is getting decolorized because it's getting added with the that C3, the C2H2. Okay. Fractional distillation. Oh no. Look, the questions, they're appearing all from the same concept. If you revise this part, then you will get what? You will just, you can answer the parts very easily. The organic part, it's very easy. Again, estimation of boiling point, structure. Ethanoic acid reacts with sodium. So ethanoic acid has CH3COOH reacting with sodium. So sodium will displace one hydrogen atom from here because it has valency 1. So it will be CH3COONA, and producing hydrogen gas. So one hydrogen atom is displaced. So to match the mole number, we have to put a half here. So two gets cancelled out to form one. Okay. Then ester. Okay, so this is an addition polymer, right? Because in the middle we see only carbon carbon, all carbon atoms. Okay, so if in a polymer you see in the middle you find only carbon atoms, then that is an addition polymer. Now how to draw the monomer? Just draw that part containing the carbon atoms only and draw the atoms attached with them. O, then CH3CO, then H, and put a double bond. Okay, this is the structure of monomer. Just find out the repeating part and then draw it like that. Okay, test for unsaturation, you already know it. You know the meaning of hydrocarbon, the molecular formula. Okay, the molar math. Incomplete combustion is hazardous because incomplete combustion would produce, carbon monoxide. We have seen in one of the question. Percentage of oxygen in the clean air. Okay, not needed. Okay, two functional groups present here in this compound. So functional group means the reactive groups. So we have only OH here. It's an alcohol, and when we have COOH, it's the carboxylic acid. So two functional groups are alcohol and carboxylic acid. So this is sodium carbonate. Carbonate is a base, so it will react with the acid part. That means this one. So this CO3 will take hydrogen atoms, and we know that CO3 has got valency 2 minus. So it will take two hydrogen atoms from here, isn't it? And will form carbon dioxide and water. And what do we get? This sodium will sit here, and sodium has got valency 1. So sodium will displace one hydrogen atom from here. So for two sodium, we need two hydrogen atom here. So let's put a 2 here. So we will get OH, OH, then CH2, CO2, and this hydrogen will get displaced by sodium. Okay, and we will get CO2 because this hydrogen will be gained by the CO3, and also we'll get H2O, CO2 and H2O. Okay. Okay. So reduced because hydrogen is getting added. So this carboxylic acid is getting reduced. Okay. Now this one is obviously not an addition polymer because in the middle we find carbon atoms attached with oxygen. So this is an ester linkage. So okay, so it's an addition polymer. Okay, so sorry, it's a condensation polymer. So how can we deduce? Look here, it's a in the middle part we find a carbon atom attached with oxygen atom, and this is giving an ester linkage. Okay, this gives an ester linkage. So in this way we can deduce that it's a condensation polymer. So we have carbon oxygen linked together, not only carbon carbon. So you can say that not only carbon carbon bonds are found along the chain of this polymer, carbon oxygen bonds are found. That is a possible explanation. And addition polymer, addition polymer, the monomer should be a molecule which contain carbon carbon double bond, but here is no carbon carbon double bond. Here is carbon oxygen double bond, but carbon carbon double bond is absent. That might also be a reason. That's a condensation polymer. Name another polymer with the same linkage. So what is the linkage found here? We have got ester linkage. So give me the name of another polymer which has the same linkage as this. It's sterylene, isn't it? Biodegradable polymers. So biodegradable polymers, they are broken down by bacteria. So this is important advantage. So they can be broken down by bacteria, and no harmful products are produced. Like addition polymers, they cannot be broken down by bacteria. So if you discharge them, they will occupy some space in the lands, and you cannot do anything useful there. And to remove them, you need to burn them. And when you are burning them, you will get harmful fumes like carbon monoxide. But in case of biodegradable polymers, the bacteria can break these polymers, and so no harmful products are produced. You can write anything from this. This question also appeared many times. Okay, and okay, so step one use of polyethylene. This is very easy. This is polypropylene. You can draw the monomer the way I have just shown a few moments ago. So here you have to describe the chromatography. Okay. Okay, photosynthesis is easy. Unsaturated, you know. Bromine, you know. Alkene, the general formula, you know. Okay. Ethanol can be formed from ethene. We have already discussed. Okay, empirical formula of this. Sodium reacts minus one. So sodium minus one. It's easy. Okay. It's double bond. Saturated and unsaturated vegetable oil. Just add bromine. On adding bromine, the unsaturated will decolorize the bromine. Margarine, producing margarine means turning an alkene like C2H4 to alkane by adding hydrogen. So just by adding hydrogen with the unsaturated vegetable oil, we can convert them into margarine. And the catalyst needed here is nickel catalyst, isn't it? Okay, complete combustion. The products, carbon dioxide and water. It's easy. Greenhouse gases, you already know. Okay, MCQs. Same type of question. Again, ethyl ethanoate. Fermentation. See the questions are repeated from the same facts again and again. Isomer of butane. Okay, isomer means that they will have same molecular formula with different structures. So I'm just drawing the carbon atoms. So this is a straight carbon atom with formula C4H10. And to draw the isomer, just change the position of one carbon atom, bring it to the middle. Okay, so this is another isomer. And now fill the rest of the bond with hydrogen atoms. Okay. So here, these are alkane, so they react with chlorine in the ultraviolet light. This is obviously a substitution reaction. We know that in substitution reaction, the alkanes, they carry out substitution reaction in the presence of ultraviolet light, and they carry out substitution until all the hydrogen atoms are displaced. We have tackled the uh, a question like this few moments ago. So okay, so C4H10, one of the product can be C4H9Cl. One hydrogen gets displaced and another hydrogen is and the chlorine sits. It can be C4H8Cl2. So one more hydrogen gets displaced and one more chlorine sits. Now you draw the structure of any one of these structures. Like I prefer to draw with one chlorine. Now fill the rest of the bond with hydrogen atoms. Okay, this is easy. In this, most of the questions are repeated from the same concept again and again. Okay, So organic chemistry, answering the organic chemistry question is quite very easy. So these are all, this question, they are from the same concept. Name the six member, predict the boiling point, then fermentation condition, structure of propanolic acid. It's all the same. Okay. Meaning of homologous series, isomer of butane. We have just drawn few moments ago. Cracking. It's all the same. Okay, so I think we don't need to discuss anything more about organic chemistry. This is easy. Okay, so this question. Not from outside, but it's within the part. So ethanoic acid, it reacts with calcium hydroxide. It's an acid, it's an alkali. So it will form salt. From ethanoic acid, we will get ethanoate. Like from sulfuric acid, we get sulfate. From nitric acid, we get nitrate. So from ethanoic acid, we will get ethanoate. And here is calcium. So we will get calcium ethanoate. And the hydrogen from here and hydroxide from here will add up to give water. It's an acid-base reaction. Then it can be oxidized, okay. Commercial use of ester, perfumes. It's easy. It's easy. It's easy. Easy, easy. Ester, butanol, and ethanoic acid, right? So butanol means the alcohol part has 4 carbon atoms. So the name will end with "-ile". So from butanol, we will get butyl. And ethanoic acid, that means it contains 2 carbon atoms. And acid part has got CO. So this is the ester which we will get. All right. This is the ester which we will get. So it's butyl ethanoate. So butanol, from butanol we get butyl, and from ethanoic acid we get anoate. I have discussed about it in at the very big. Converting ethanol to ethanoic acid, by adding oxidizing agent, a limited supply of air, so less oxygen. So on burning a butanol, we will get carbon monoxide and water, or we will get carbon and water. Okay. Same type of question. Same type of question. Repeat, repeat, repeat. Okay. So that's all for alkane, alkene, alcohol, and carboxylic acids. All right. So if you get to study these questions, okay, let's draw this again. I know you can draw it, but still, okay. So from here, we just need to remove the double bond and draw the repeating units. So nothing is mentioned. So you can draw the repeating unit once. Now, if you draw once, you have to put an N, or what you can do is that you can draw these things 3 times, thrice. All right. You can draw these things how many times? Thrice. Okay. So difference between addition and condensation polymer, in addition polymer, the monomer has carbon-carbon double bond, but in condensation polymer, the monomer doesn't have any carbon-carbon double bond. In addition polymer, carbon-carbon, all the links are carbon-carbon, but in condensation polymer, in the middle part, we have other atoms bonded to carbon atom. Basically, oxygen is found there. Okay. Okay. Still, let's see the answer, what they have given. Also, style of polymerization. So in condensation, small molecules are released like water, but in addition polymer, nothing is released. Just the double bond is broken and they get added together. That is also correct. And if you write the structural difference, that would also be correct. No problem. Ethanic acid. It's easy. It's easy. Weak acid. Weak acid. Weak acid. Okay. Now we need to draw the structure of monomer. Okay. So what was the rule? Let's deduce the repeating unit and take one of the repeating unit. So what we are getting here, CH2, C2H5, CH2, C2H5. So this is the repeating unit. All right. So let's draw a repeating unit, CH2, C2H5. And now let's put a double bond between these two carbon atoms, just like as before we have drawn, right? Okay. Let's see the next question. It's all the same. It's all the same. Weak acid, reacting with magnesium. It's all the same, all the same. Incomplete combustion. Chemical test. Constant the same equation with potassium. They have already given the hints. You know, this reaction of alcohol and this metal is not in our syllabus. So they have given the hints. Just follow these hints and write the reaction. Like sodium has got valency. So what is the hints? Look, here it was OH, but here it's ONA. So sodium has also displaced hydrogen from here. So metal will displace hydrogen from alcohol also. This is the hint. Now using the hint, draw it. Test for hydrogen, you know, it gives a pop sound with a burning splint. Ethanoic acid, all the same. All questions are basically the same. Okay. So let's find the structure of this monomer. Obviously, it's not addition polymer, it's a condensation polymer. Look what we have. We have, instead of carbon, we have silicon here. So imagine these silicon as carbon atoms. Now draw a repeating unit. Okay. Look, this part is being repeated again and again, isn't it? This part is being repeated. So let's draw this part. So it's Si, then C2H5. It's the condensation polymer. It's C2H5. So we have O this part and a bond this side. So here what we have. Okay. So basically after breaking down a condensation polymer, we have to attach HOH. Okay. So the thing which is different or are different atom, we will attach H, and with the carbon atom or anything. So here I have just told that this carbon and silicon, they're in the same group. Just to confuse you, they have put silicon here. So, and with the carbon atom, we will attach OH, and with the other atom, we will attach H. Look, this H is attached here. Okay. So this was the repeating unit. So this was the repeating unit. Okay. So with the carbon atom, we will attach OH, and with the other atom, we will attach H. Okay. So this is the monomer. Look, let me tell you. For example, COO. Okay. So you break down from here. So we have O here and we have CO here. So with the C, we will attach OH, and with the other atom present here, we will attach H. It may also be nitrogen. Okay, it may also be nitrogen. All the same question. All questions are the same type. Okay, aqueous bromine can be used. We have already discussed. Potassium manganate, the color changes from purple to colorless. Okay, That's all for our organic chemistry questions. I think we don't need to discuss more. Okay, so that's all for alkane, alcohols, and carboxylic acids. In the next video, we will discuss about. So this is the longest part, I guess. So in the next video, we will discuss about polymers. All right. Okay. Thank you. So this is the second part of our organic chemistry lecture, and in this lecture, we are concerned on the topic macromolecules. So here we will also be solving some sample questions. For example, look here. So this here in this molecule, it's a type of polymerization as they have stated, or a polymer is being broken down. So look, this is a condensation polymer for sure, isn't it? Because we are getting oxygen atom here. So starch is obviously a condensation polymer because there are COC linkage. So when a condensation polymer is being broken down, we must add water, isn't it? Uh, you may remember that when we are breaking this ester linkage, we are adding OH with CO and H with O, and this comes from water. So the condensation polymers needs to be broken down by water. All right, they must be broken down by water, and therefore these reactions are called the hydrolysis reactions. So when condensation polymers are broken down, we call them hydrolysis reactions. And when the condensation polymers are formed, we call them condensation reactions. All right. So here the answer is hydrolysis. Okay, now let's go to some theoretical questions. So here some polymers are shown. Look, this is nylon. This polymer is nylon. We get the NHCO bond, which is known as the amide linkage. What kind of linkage it is known? It's the amide linkage. Okay. And here we have the ester linkage. This is the pterylene. Okay, we must look at the linkages. It's NCCN, NC, and then CN again. Okay. And here it's CO, sorry, it's OCCO, OCCO, OCCO. These are the pterylene. All right. Okay. So nylon and pterylene we are getting. Okay. So how to get the polymers from here? Now let's look at the repeating units. Okay. So what is the theme? The theme is we have to break in between the in between the carbon atom and a different atom, and the different atom to which it is attached. So CN breakdown between CN. So this is a monomer, this is a monomer. That means these are the repeating units, isn't it? Repeating units. Okay. So, okay. And here in the pterylene, this C, and the different atom to which C is attached is the O here, right? O here. So let's break in between them. So we have this one as a monomer and this one as another monomer. That is the repeating units. Okay, right. Now, let's go to the question. Okay, draw a circle around an amide linkage and label this as amide. Okay, so as I've already told, this is the amide linkage. Now, what is our next question? Draw a circle around ester linkage and circle it as ester. So This is the star linkage, isn't it? COO, or this is an star linkage, the COO. So now we will label this as ester. Okay. Now name a type of naturally occurring polymer which has a similar linkage to that of nylon. Okay, now this is a very important thing. Now look, nylon and protein, they have got the same type of linkages. But look, in nylon we have NC and then CN, then we have NC. And in proteins, it will all be the same. It will be CN and then something something and then CN something something, or it will be NC something something then NC something something, isn't it? Here it's a twist and trust, but in protein it will remain the same. Either it's all NC or it's all CN. Okay. So the similar type of amide linkage is found in also protein. Okay. The formula of the two monomers used to make nylon, okay, are shown below. So deduce the formula of the two monomers that is used to make pterylene. Okay. So as I have already told that how to get the monomers. So what you will do, you will break in between the carbon atom and the different atom to which this carbon is attached. Okay, break down. Okay, and oh, sorry. So with the carbon atom we will attach OH, and with the other atom we will attach H. With the carbon atom we will attach OH, and with the other atom we will attach H. Okay, so look, it's COOH, CH2, COOH, right? And this is given here. COOH, then CH2, or 4 of the CH2, then COOH. Okay, then similar here, like when breaking down this, so with the other atom we attach H, with the other atom we attach H. So it's NH2, CH26, NH2, isn't it? Look, NH2, CH26, NH2. And in the same way, we will break down the ester between the carbon atom and the different atom. So broken down. So with the CO, with the C, we'll attach OH, and with the other atom, we will attach H. With the C, we will attach OH, and with the other atom, we will attach H. So one of the monomer we are getting is this. So one of the monomer will be COOH, then C6H4, then COOH, COOH. And another monomer is OH, OH attached with CH22, CH22 attached to another OH. Okay, so these are the monomers of the answer. We have got it. Advantage and disadvantage: nylon is very strong, biodegradable, and disadvantage is right in the way you like. A possible disadvantage might be it may be expensive. Okay, it may be expensive, so that's a possible disadvantage. Or it's synthetic, that means man-made, which may not be preferable for us. Okay, so what is a macromolecule here? Look, so this is carboxylic acid. OH goes from here, and this is OH. The H goes from here. So we are left with CO and O. So these are polyester. This is easy. Okay. Okay. Now let's look at this question. Macromolecules. Macromolecules are large molecules built from many small units, okay, proteins and pairs at method, okay. Okay, polychloratin and polyethylene are synthetic molecules, all right. So, um, name the type of linkage joining units in fats. So you must know that fats, these are also type of polyesters. Okay, so the type of linkage found in fat is ester. Okay, proteins can be hydrolyzed, that means broken down by water into monomers, boiling with concentrated hydrochloric acid. Now this line is important because all hydrolysis reactions are carried out basically by heating with concentrated acids. Okay, so name the monomers produced in the hydrolysis. So on breaking down proteins, what you get? You get amino acids. And in these compounds, so one side contains the amine group, that means the NH2, and the other side contains the carboxylic acid group, that means COOH. So that's why amino acid. Okay. Suggest why cloths made from nylon are damaged by concentrated hydrochloric acid. So simple. This is because nylon is also a condensation polymer. So they can be hydrolyzed into monomers by boiling with concentrated acid. So that's why they are broken down. Uh, the nylon cloths are easily broken down by concentrated acids. So here in that question, that disadvantage, a possible answer can be like they are easily broken down by acids, heating with acids. So that's a problem. All right. Okay, we are not yet done with that question. So this is a polychloro. This is a chloroethene. So we need to draw the structure of chloroethene. We have already discussed the fact in the first lecture. What is the fact? So this is the monomer, that means this is the repeating unit. So we draw it, and poly means many. So we draw it. So nothing is mentioned that how many units we need to draw. So we may draw one unit, and if you draw one unit, then we have to put n. And if we draw two or three repeating units, we don't need to put n. So this can be the answer. Or drawing this twice or thrice can be the answer. Everything is accepted. So polychloroethane has a low melting point, and since the question asked about low melting point, so organic molecules, when you are talking about the melting or boiling point, this means you have to talk about the attractive force between the molecules. If the question says that the melting point is high, then the attractive force between the particles is also high. If the melting point is low, the question says, then the attractive force between the particles will also be low. Okay, weaker. Okay, bromine reacts with chloroethene. So we've already discussed, because here is a double bond. So bromine will get decolorized. Bromine will not react with polychloroethene because in polychloroethene, the double bond is broken and we will get all single bonds, right? Okay. Now let's go to the next question. Explain why plastics such as polychloroethene may cause pollution. For two reasons mainly. First of all, they are not biodegradable. That means they are easily broken down. Sorry, they are not biodegradable. That means they won't be broken down by reaction with water and using bacteria. They won't be broken down. And secondly, when they're burned, they give out harmful fumes, right? Okay, so these are the two problems. Okay, so which will get hydrolyzed to amino acids. That means one side will contain the amine group and the other will contain the carboxylic acid group. So this is ester linkage. No nitrogen is present here, so no amine can be formed. Okay, let's look here. We are breaking from the middle, the C and N, C and N, C and N. So here we will get we are having both side carboxylic acid and we are having both side amine. So we are not getting amino acid from here. Okay, we may get amino acid from here. Let's break from between the carbon and the different atom. So look, this monomer, it contains the carboxylic acid group and the amine group. So this is an amino acid. So the answer would be D. Okay, now you might ask that what else if this is broken down? Okay, so here is an oxygen we find. Okay, so what you will do, we'll consider carbon at one of the side, carbon. Okay, now break between that carbon and the other atom, carbon and the other atom, carbon and the other atom. Okay, so let's draw this part. So we will attach OH with that carbon atom, OH. Okay. Oh, the carbon is inside the box. So, okay, we have to consider that the carbon atom is inside the box. So, here the carbon is attached. So, with carbon we will attach OH, and to the other side there is O, which is considered as a different atom. We will attach H here. So, this is the monomer of this starch. This is starch. Okay. So, okay, you can deduce the polymer easily from here. So first of all, this is an addition polymer, all carbon atoms in the middle. Now how to draw the monomers? So let's take out two carbon atoms. This is the repeating unit here. You can also see this is the repeating unit here. And we have Cl and we have H. Now we put a double bond. So this is the monomer. Okay, so which one may be the answer? D is the answer. Weak acid. Oh, this is easy. State the functional groups present here. So ester group is present here. Ester group is present here. Ester, and this is the structure of pterylene. COOC. COOC. Okay. So what can be the monomer? The monomer is, let's break from the middle between the carbon atom and the different atom. Look, it's all the same concept, all the same concept. So with the carbon atom, we attach OH. With the other atom, we attach H. H, OH, OH. So if they ask you about the monomers, so one monomer will be both side containing OH, and the other monomer will be both side containing COOH. And what type of polymerization is occurring here? Obviously, this is a condensation polymerization, because with carbon atom, we have a different atom attached here, which is what? Which is oxygen in this case. Okay, state one large scale use of pterylene. So the last answers are very important. So large scale use of pterylene is like, the cloths, the polyester cloths. And then, okay, the disposal of polythene problems, the plastics, because they are not biodegradable, because they are not condensation polymers, so they are not biodegradable. So, and when they're burned, they give out harmful fumes. We have already discussed this in the last lecture. Okay, so these are all, same type of repeated questions. Polymerization is actually very easy. It's actually easy. Okay, so fumaric acid, it reacts with aqueous bromine. Why? You don't have to write the reaction here. Oh, sorry, giving the reaction. Okay, so bromine would get decolorized, and how you would write the reaction? Look, here is a carbon-carbon double bond we find. So let's make it a single bond. So what you can do is that you can use the general form, the molecular form to write the reaction. Look, so you can write COOH. You must write it reverse. because you have to show the bonding between carbon and carbon. So here we have H attached, and then carbon carbon double bond, and then H attached here along with COOH. COOH. Now when bromine is added to it, so what we get? We get COOH, then CH, then CH, the double bond gets broken and two new bonds are formed, COOH, and with the two new bonds, the bromine atoms are added, and the bromine becomes what? The bromine becomes colorless. Okay, so that's the reaction and the observation. This is mole math. Okay, so this is the condensation polymer which is made by fumaric acid reacting with this diol. So here is an alcohol group, it's an alcohol group here. And what we have here, we have carboxylic acids here. So alcohol and carboxylic acids, they together would give what? They would give esters. So the type of polymerization you will get is an ester. C. The answer of C is ester. Nylon D. Okay. So we know the use of nylon, the problems caused by non-biodegradable plastics. We have discussed about this several times. So draw the structure of monomer from here. This is an addition polymer. So how to draw the monomer? Take out this repeating unit and put a double bond between them and omit these bonds. We have also discussed this. Okay, this is simply the burning reaction. Okay, so this is an addition polymer. Okay, draw the monomer. So take out two carbon atoms, or take out a repeating unit. Take out a repeating unit. Take out a repeating unit, and then put a double bond between them. Okay, same type. This is a saturated hydrocarbon, this polymer. Why? Because all single bonds, not destroyed in water, because this is not a condensation polymer. That means there are no amide linkage or there are no ester linkage. Same time, all same. Okay, proteins are naturally occurring macromolecules. So macromolecules means very large molecules, isn't it? Okay, let me show the answer. Macromolecules means they are very large molecules. So giant molecules, large molecules, long molecules, they are all synonymous. All right. Okay. So now chromatographic identification. You must memorize this part because as you can see that these questions are frequently appearing. Chromatographic analysis. So look at the year of this question. So this is May, June, October number 10, paper 2. Okay. So protein can be hydrolyzed to amino acids. And just in the first question, we have studied the conditions for hydrolysis. That means heat with concentrated acid, isn't it? Heat with concentrated acid. We have already studied that part. Reagent is concentrated hydrochloric acid, condition is heat. So simple. Okay, so now this monomer, look, this monomer, all right. This is a what? This is a protein because the linkages are same, like CN, CN, then CN, then CN. So same linkages are formed. So what is the similarity between nylon and protein? The similarity is both of them contains what? Both of them contains the amide linkage. Okay, and the difference is structure of protein differs from structure of nylon. So as you can see, as I've already told, that the monomers are attached. Sorry, the linkages. Look what they have said. So only one. Okay. So that's not the way of answering this. I mean, they have given the question from one sense and they have answered it from other sense. Okay. Okay. So inside nylon, one one uh, one one unit. Sorry. Inside protein, one of the unit, a box with two atoms attached to it is a unit. So one unit has amine group on one side and carboxyl group on one side in protein, but in nylon, what happens? If you can find the structure of nylon, I've seen a few moments ago. Okay, in nylon, what happens? Okay, forget it. Let me draw. And in nylon, what happens? We have, suppose this is one unit. So both side contains N, then CO, CO, right? Okay. So one unit has amine groups on both sides and the other unit has carboxyl group on both sides. So that's the difference. Okay. So these are all sort of easy. You can do it. You can do it. You can do it. What? Name a synthetic polyamide. Synthetic means man-made polyamide, and amide, amide linkages are found in protein and nylon. So protein is natural, and synthetic means man-made. So it's nylon. It's easy. It's easy. All of it. Okay. Disposal of the same type of question. Disposal of non-biodegradable polymers. Okay, so what type of polymerization is occurring here? Obviously, condensation polymerization is occurring here. Partial structure to of nylon. Okay, so nylon, remember it's CN, then box, then NC, then another box, then again CN. So you break it between them, break. So with nitrogen, we attach hydrogen, although there was another hydrogen attached, already attached here. With nitrogen, we attach hydrogen. So in one side, we attach like NH2 and then NH2. And in the other side, we will attach COOH, then COOH, right? COOH and COOH. With C, we will always attach H, and with the other atom, we will with C, we will always attach OH, and with the other atom, we will attach H. Okay. Same linkage is the sterylene. Sterylene contains ester linkage, and we have already learned that fat also contains ester linkage. Okay, that would do for polymers. Nothing extra needed. So this one. So in here, look, all the linkages are the same format: NC, NC, NC. So it's an amide linkage, and since they appear in the same format, so it's a protein. It is a protein. Okay, and you can answer this question easily. Okay, a chromatographic question. This is very important. Paper chromatography. How would you identify them? I would suggest you to memorize the answer of this question. This part. Okay, you may prefer to take a screenshot. I know you can already answer all by yourself, but still, I'm telling you. Unsaturated test for unsaturation. We already know the fats. Same linkage as sterylene. Okay, so protein, it should contain nitrogen. So here D is the answer. Okay. You can answer this question. Look here, all the polymers are given. So this is a good question. So terylene, this is terylene. This is a PTFE, an addition polymer. That is nylon, that is starch. And for revision again, I am telling you, in one side of the box, you will consider that a carbon atom is there. Okay. And when you break down the starch, with the carbon atom, we will attach OH. And with the other atom, we will attach H. The carbon atom, it's always OH. And with the other atom, it's always H. Right? Okay. PVC is protein, then polyester, then polythene. Okay, you can easily answer this question. Hydrolyzed means broken down by water using concentrated acid. So which one broken down to simple sugars? Starch are broken down to simple sugars. So this is the structure of starch. We have already told this some moments ago. So polymer D can be broken down to starch, right? Okay. So polymer D can be broken down to starch. Okay. Sorry, simple sugars. Okay, done. I think that would do for these are the same type of questions. Now, what is the meaning of addition polymerization? That means in addition polymerization, no small molecules are lost. That means the molecules are just added, the units are just added. No loss of small molecules, no loss of mass. But in condensation polymer, small molecules are lost. That means some masses are lost. Pollution problem caused by the disposal of addition polymer. You know that plastics and polyethylenes, these are all addition polymers. So they would remain the same. Yes, that would do for polymers.